Welcome to this YSL Excel VBA tutorial. This video is going to explain how you can replace strings using VBA code, and it's all focused around using the replace function in VBA. So we'll start with a quick simple look at how you can replace both single and multiple characters in a string, before we move on and look at how you can then control the number of replacements that get made and the starting position within the string from which replacements are made. We'll have a quick section that talks about how to deal with case sensitivity, and then right at the end of the video we'll look at a slightly more practical example for generating valid file names from the contents of cells, so essentially replacing the illegal characters in a string. So plenty to do here, let's get started. Okay, well the starting point for this video is our fairly standard workbook full of movie data. If you need a copy you can grab one from the link in the video description, or alternatively if you've watched the previous 2 or 3 videos in this series, we're going to use exactly the same data for this one, so feel free to carry on using that same file. Whatever you decide to do, you'll need to head to the VB editor, so of course you can hit Alt and F11 to do that, and then we'll insert a new module into the workbook, and then we'll create a new subroutine called something simple like replacing strings. So this is just to give you the absolute basics of how replacing strings works. What I'd like to do is declare a simple string variable, so I'm going to say dim s as string, and then I'd like to assign a value to that variable, so I'm going to say s equals range a4 dot value. Finally, just for this simple introductory part, we're going to debug.print the value of that string so that we'll be able to see what's stored inside it, which will obviously be the phrase King Kong, or that film's name. So what we'll do now is start looking at how we can start replacing bits of text within that string. Let's start with something quite basic then. All I'd like to do to begin with is replace the letter K in the phrase King Kong with another letter. So to do that I'm going to use my variable s, and I'm going to assign a new value to it using the replace function. If you press Ctrl and space on the keyboard and look for the word replace, you'll see there's a method sitting there in the IntelliSense list. If I open some round brackets or parentheses, you'll see there's a great big long list of parameters. There's only 3 compulsory ones though: expression, find and replace, and all 3 of these things must be strings. So the expression I'm looking within, the string that I'm looking within to replace some text, is what's currently contained in my variable s. Follow that with a comma. The string I'm trying to find is the letter K, so I'm going to enter that as a literal string in double quotes, and I've made sure that it's a capital letter K there as well. That's important at this point. The string I'm trying to replace the letter K with is, well, we could choose whatever we want. Let's go with the letter S to begin with. If we then have another debug.print statement immediately below and print the value of s again, if I were to simply run the subroutine, we'll see the 2 different versions of the phrase that I've returned. So I've got King Kong and Sing Song. So that's a bit of a silly example, admittedly. There's several other silly examples we could have done there as well. We could have replaced K with P and got ping pong, or K with D and got ding dong, and so on and so on. So you see that whatever letter you've looked for, whatever string you've looked for, it replaces every instance of that string with the new string you've chosen. Now you're by no means limited to replacing one single character with just another single character. You can make these substrings pretty much as long as you like. So just for another couple of slightly silly examples, let's have a go with replacing the letter K with the phrase dilly dee, and if I were to run that subroutine I'll end up with the phrase dilly ding dilly dong. And that example will make an awful lot more sense to you, by the way, if you follow English football. If you don't, then that will be a little bit of a strange, obscure example, but anyway, there is a reason behind that particular phrasing. What else can we do? Let's have a look at maybe changing the cell reference we pick. So let's pick cell A1150 rather than A4, and in there I'm going to replace the phrase, or the letter M, with the 2 letters TR. And if I were to run that subroutine, I'll end up with the film Magic Mike being converted to Tragic Trike, which kind of changes the flavour of the movie a little bit. What else could we do? Let's have a look at range A637, and this time I'm going to replace a couple of characters with a single character, so sort of flip this around. So let's say I want to replace the letters GR with the letter actually I want to replace this with absolutely nothing. I want to replace this with an empty string. So effectively this is going to take away the letters GR from the name of the film. So if I were to execute that subroutine now, I'll end up with the Grapes of Wrath being converted to the Apes of Wrath, which should definitely be the subtitle for the next Planet of the Apes movie, absolutely for sure. It's a bit of a shame in this case that the letter A isn't a capital letter, so I don't get this sort of proper case where you get the first letter of each word being a capital letter. So it might make a little more sense for this, if this example makes any sense whatsoever, it might make more sense to replace the letters GRA with a capital letter A. And then if I were to execute that one now, it looks a little more like the specific title I was looking for. I just clicked into the wrong part of the immediate window there. Let me just run that one again so you can see that it's working as intended. So there we go, Grapes of Wrath to the Apes of Wrath. Occasionally, you may need to make a sequence of individual replacements to reach the final string you're trying to achieve. So let's make another couple of quick changes to our subroutine. Let's look for cell A289 this time. And what I'm going to do here is replace the phrase "Twilight" with the phrase "Arable." And then if I were to execute that subroutine at that point, I'll end up with the Twilight Saga being converted to the Terrible Saga, which is a much more appropriate title. But we're not quite there with this title yet. There's a few other problems. I mean, there are many problems with the Twilight Saga. Let's not get into that right now. But there are several other problems with this particular title I need to change. First of all, the word saga. I don't know if you guys know of a game called Candy Crush Saga, like a mobile phone game, Candy Crush Saga. It's almost as bad a game as Twilight is a movie. But anyway, the important thing here is that once upon a time, the company that made the Candy Crush Saga tried to trademark the word saga, which had an implication for another video game that was coming out at the time called the Banner Saga. So they tried to sue, and it was all a horrible mess. Anyway, it all got resolved. The important thing is we might want to avoid using the word saga in our movie title. So what I've done is I've looked up the actual definition of the word saga, and here it is. Just a quick Google saga definition, and I've got something here: a long involved story, account, or series of incidents. So I'm just going to copy that string there. And then if I go back to my VB code and have a look at adding another replace, so I can say below the original replace, I can say s equals replace, open some parentheses. I can use the same string, which at that point will contain this phrase, the Terrible Saga, but in here I can look for the word saga individually, and then I'll spell that properly. I'll get the string that I've just copied and paste it in. I think I've just missed off the letter L right at the start, so let's stick that in there as well. Close the parentheses at the end, and then let's have a quick test of that one. If I run that one, I'll end up with a terrible, long, involved story, account, or series of incidents breaking dawn. Nearly there. One last replacement to make. I'm going to add another replace at the end, which will be s equals replace. And then again, I'm going to replace what's currently held in the s variable. I'm going to look for the letter D, capital letter D, and then replace that with a capital letter Y. And if I close the parentheses, run this one final time, I will end up with a film title called The Terrible, Long, Involved Story, Account, or Series of Incidents Breaking Yawn Part 2. That's a much better name and a much more appropriate title for that absolutely awful film. Okay, let's move on a little bit and look at a couple of the other parameters of the replace function. I'm just going to clear the contents of the immediate window so we've got a bit of a clear space to work with, and then I'm going to make a few modifications to this procedure again. I'm going to get rid of, or I'm going to change the cell reference from 289 to 279, and then I'm just going to remove a bunch of these replace lines, 2 of them at least, to leave us with one single one. And what I'm going to do here is I'm going to replace the letter F with the letter L. So I'm going to say F, capital F, and then capital L. I'm just going to comment out these 2 lines to start with, and then I'm going to run this subroutine without the replaced version. If I run that one, we'll end up with the film Fast and Furious 6. It never made much sense to me why people would be both fast and furious. I can imagine being furious if you were last in a race, so what we'll try and do is create the last and the furious, which makes a huge amount more sense to the title of that film. So if we just uncomment those 2 lines I've just commented out, I'll end up with, this time, the last and the furious, which I'm not quite sure is an English word. So what we need to do here is make sure that we only replace the first letter F that we encounter in that title. So there's a parameter that allows you to control how many instances of a character or a substring that you replace. If I click back into the parentheses in the replace method and start typing in commas, you'll see that I get a bunch of extra optional parameters, and the one that I'm interested in here is the count parameter. So if I type in a couple of commas to reach that one, I could have also named my parameter, so I could have said expression : s, find : f, etc., but it's slightly more convenient just to avoid typing in parameter names. So all I want to do in this case is I only want to replace the first instance, or I only want to replace one instance of the letter F. So if I were to enter that and then run the subroutine, I'll end up with the last and the furious, which makes an awful lot more sense as a movie, I think. So we've seen how to replace just the first instance of a character in a string, but what if you wanted to replace a later instance? So let's say I wanted to flip this around so it was fast and furious, for instance. It's not just sufficient, of course, to change the count argument from 1 to 2, because all that will do if I were to run the subroutine is replace the first 2 instances of the letter F. If you want to replace a later instance and not touch the first, we need a slightly different approach. So let's just change this around a little bit. Let's go for a slightly different film this time. I'm going to go for the film in cell A18 this time. And then I'm going to change the letters I'm looking for from the letter O to the letter I, and I'm going for lowercase letters this time, and I'm going to remove the extra arguments I filled in earlier on, just go back to the first basic 3 arguments. If I run that subroutine at this point, I'll get Harry Potter and the Goblet of Fire changed to Harry Pitter and the Giblet if Fire, which sounds like a slightly more interesting movie to me. I don't know, I never watched it. I wasn't really into Harry Potter, sorry. What I want to avoid in this case, though, I don't want to change the actual title of the movie too much. I want to replace Goblet with Giblet, because that sounds kind of fun. But I don't want to replace Potter with Pitter or of with if. So to achieve that, we've got to take a slightly different approach. We can solve part of the problem by telling the replace function only to start replacing characters after a certain position in the string. So every string in VBA is indexed, where the first character is index position number 1, and the second is number 2, and the third 3, and so on. So if we can tell the replace function to only begin replacing characters after the first letter O, so that occupies position number 8, so if we can tell it to start replacing characters from position 9 onwards, that will solve part of the problem. So let's just clear the contents of the immediate window, and then let's enter another argument for the first optional parameter, the start parameter. If we tell it to start at position number 9 in the string, and then if we were to run that one, that will solve part of the problem for us. You can probably see a big problem with the rest of it. So the original string is, of course, Harry Potter and the Goblet of Fire. Now what I've got starting at position number 9, which is the letter T there, I've got all of the rest of that string with any letter O's replaced with letter I's instead, so the Giblet if Fire. The problem is, of course, that I've now lost the original part of the string, so we'll solve that problem separately in a moment. But the cool thing is here, we can tell it to start at a particular position. Now it's a little bit annoying that we had to manually key in the value 9 for this particular technique to work. It would be much more convenient if we could have calculated the position of the first letter O and then added 1 to that position to tell it where to begin replacing characters from. So if you watched one of the earlier videos in this little mini-series about strings in VBA, you'll be familiar with the instring or the instra function. So if we replace the number 9 with a reference to the instra function, we can tell it to start looking at character number 1, and then we can say we want to look in our string variable, and we're looking for a lowercase letter o. If I then close a parentheses, that little part of the expression will calculate the position number 8. That's the first instance of the letter O in the phrase Harry Potter. I want to start looking at character number 9, so if I add 1 to that, of course, that will end up with exactly the same results as I had last time. Let's just clear the contents of the immediate window and then execute that again, and I'll end up with the exact same results, but with the convenience of not having to know what position the first letter O occupies. It might also be worthwhile at this point solving the problem of replacing the word of with the word if. I only want to replace the first instance of the letter O in the remainder of that string, so we can solve that problem as we did earlier on by specifying a count. So I set the count to 1, so only replace the first instance of the letter O in the remaining part of the string, clear the contents of the immediate window, and then run that one more time, and that will give me the second half of the string that I want. The last remaining problem is to return the left-hand side of the string, so I want to get the Harry Potter to join all that back together to form a full film title. Now one way to achieve that is using the instring function again. So if I know what position the first letter O occupies, I can get all the characters from the left of that side of the string, or from the left of that character's position in the string. To avoid having to write out the instring function again, it might make sense to declare a variable that will hold a reference to that number. So I can say dim, I'll just call it I as integer for now, and then I can say that I equals, beg your pardon, let's try that again. I can say I equals, and then I'm just going to copy and paste my instring function. So if I copy that there, and then rather than putting my instring function inside this string, what I can do here is replace that with a reference to my variable I. That helps because what I can now do is also concatenate the first part of the string. So rather than just using the replace function, what I'm going to do here is say s equals left of s, comma, and the number of characters that I want to return first is the first 8 characters, so that's going to be equal to the letter I, so that's my variable which contains the position of the first letter O. Then I can concatenate that using an ampersand with the rest of the string that I've just calculated here. So it's a little bit awkward, and I'm not sure you're likely to do things like this in the real world, but just to sort of show you how far you can go with this, if I do finally run that subroutine, I do indeed end up with Harry Potter and the Giblet of Fire. Okay, one thing we haven't dealt with so far is the issue of case sensitivity in VBA strings. Let's have another quick separate subroutine for this one, just to avoid having to replace too much in the original one. So I'm going to create a new sub called case sensitivity, if I can spell that properly. There we go, nearly. I will get there, I promise. Case sensitivity. And I want to begin by declaring a variable called s as a string, and I'm going to set s to be equal to range, and then the cell that I'm going to look for this time is A73. And I'm going to refer to the value property of that range. Then I'll say debug.print s just to see what the original value of that string was. And then what I would like to do is replace in that string. So I'm going to say s is equal to replace, and then open some parentheses, and then say inside the string I want to replace the letter r, which will be a capital letter R, with the capital letter W. And then if I finally debug.print the resulting string, debug.print s, clear the contents of the immediate window, and then run that subroutine, I'll end up with the Lord of the Rings Return of the King replaced with the Lord of the Wings Return of the King. So we've got the capital letters R's replaced with capital letter W's. What we haven't done is replace the lowercase letter r's. You'll see that those are completely untouched. So by default, as you'll know if you've watched the first video in this little mini-series about strings in VBA, by default, VBA is case sensitive when it comes to comparing strings. There are a couple of different ways of making string comparisons case insensitive in VBA, but with the replace function the technique is quite simple. There's an extra optional parameter called compare, which allows you to choose what type of compare mode you want to use. So the default in VBA, unless you've changed the option compare statement at the top of module, the default is binary compare, which is effectively case sensitive. Database compare you wouldn't use in Excel VBA, that's reserved purely for access databases, which will match the compare mode you've set for the actual database file. The text compare mode, however, is the one we're going to use here. Text compare just compares the character, whether it's uppercase or lowercase, it doesn't matter. It essentially makes the comparison case insensitive. So if I were to set that to VB text compare, just clear the contents of the immediate window, and then finally run that subroutine again, I'll end up with all the letter R's, regardless of whether they were uppercase or lowercase, replaced with capital letter W's. Now, apart from the fact that this title now makes no sense whatsoever, it's completely unreadable, one slightly weird thing about this is that, of course, even though you replace the lowercase letter r's, they were replaced with capital letter W's. Now, if you wanted to make sure that the string was a little more readable than it currently is, making sure that we had perhaps proper case, where the first letter of each word is a capital letter, but every other letter in the same word was a lowercase letter, we can do that reasonably easily in VBA with the string conversion function, or string convert function, or strconv as it's called. So if we say s equals strconv, and then open some parentheses, we've got to refer to the string we want to convert first, which is s, and then we choose a conversion mode. Now, ignoring the exciting sounding ones that refer to Japanese character sets like hiragana and katakana, what we're going to do here is refer to proper case. So I choose proper case and then close the parentheses, clear the contents of the immediate window, and then run that subroutine again. We'll end up with the proper cased version of that completely nonsensical title. Now that was quite a simple, easy way to show you how the proper case works. This was quite a convenient string to use because the first letter of each word immediately followed a space character, and that's how proper case works. The first letter after each space is converted into an uppercase letter. But your strings will always be formatted in quite as convenient a way as that. Let's show you another example. We'll use the same subroutine actually. Let me just copy and paste this entire section of code and drop it in immediately down below. We'll make a couple of changes, so we won't look for cell A73, but look for cell 1144. And then rather than replacing the letter R, I want to replace the letter A with the letter E. And I want to make sure that it's a text compare rather than a binary compare. So there's a capital letter A and a lowercase letter a that I want to convert. And then if I were to run that subroutine, what we'll end up with is Ant-Man being converted to Ent-Men, which I thought was quite a nice subtitle for The Lord of the Rings Return of the King. I suppose more for the Two Towers than Return of the King, but let's not split hairs. Anyway, the important thing is that although we had Ant-Man with a capital M originally, we've now got Ent-Men with a lowercase m, even though I used proper case. And that's simply because there's a dash symbol separating the words rather than a space. So what we could do to solve this particular problem is replace the dash symbol in between ant and man with a space symbol. So we can do that in a couple of different ways here. It depends on whether we want to get the dash symbol back at the end. Probably the easiest way to do this, I think, would be inside the string convert function. Rather than converting the existing string, I'd want to convert the replaced version of that string where the dash is converted to a space. So let's have a quick go. I'm just going to copy and paste, actually, just for convenience. Copy and paste my replace function here and paste that over the top of the S and then close a set of parentheses there. And then I'm going to enter a dash character there and replace that with a space character. So what that will do is, if I were to run this one so you can see the results, is I end up with a space character with ent men, but I've lost the dash. So if I wanted to replace the dash, what I could do is replace spaces in the result of this expression with a dash character. So let's have a quick go. If we wanted to do that, just to show you how ridiculous this can become, let's say replace, sorry, beg pardon, I'll get there eventually, replace, open some parentheses. This is the string that I'm trying to replace, and I want to replace inside that string any space character with a dash character. And then if I were to run the final result of this, I'll end up with the ent men movie. Now I think you'll agree that up to this point in the video, all the examples we've used so far have been fairly silly in nature. Hopefully they've been a bit entertaining for you as well, though that wasn't quite the point of showing you the replace function, not just to have a bit of fun. In the correct circumstances, the replace function can be incredibly useful. So just to wrap up the video, I'd like to create something that's a slightly more practical example that uses the replace function to perform a particularly useful job. What we're going to do is generate a bit of code that creates a new text file for every unique film name in this list. There's about 1,200 films here, but there are multiple instances of some films, so there are several instances of King Kong, for instance. So what I'd like to do is generate a separate text file for each film title that contains the details for every film with that title. Now what I would also like to do at that point is use the film's name as the file's name. So the film title becomes the file name, and that's going to cause a problem in certain circumstances. Let's just start by setting up the basics of that procedure. I'm going to head back to the VB editor and first of all clear the contents of the immediate window. And I'm going to have a brand new module for this as well, so I'm going to right click and insert module. I'm going to create a new subroutine in here called create film files. This is going to rely on using some techniques using the Microsoft Scripting Runtime Object Library. So if I haven't got that one referenced already, I need to go to the Tools menu and choose References. And then in the list of references that appears, I need to scroll all the way down to find Microsoft Scripting Runtime. It's easy to scroll all the way past this, as I've just done. Microsoft Scripting Runtime, there it is. Make sure you place a check in the box next to that line. Don't just click onto the line. You must make sure there's a check there. Click OK. Then there's a few variables I'd like to create to get started. I'm going to say dim FSO as a new scripting.filesystem object. That helps us to manipulate files and folders. I'm going to have a variable that holds a reference to a text file, which is what I'm going to open up to write my data into. So I'm going to say dim ts as scripting.textstream. I'd like to declare a variable that holds a reference to a range object, so I'm going to say dim r as range. That's going to allow me to loop over the entire list of film titles. I'm going to have a variable that holds a name for a folder path. I'm going to generate a folder that will hold all of these files. There's going to be about, well, there are 1,200 films in the list, and not many of the film names duplicate in those 1,200, so there's going to be an awful lot of files. Let's have a variable called folder path as string, and that will hold the name of the folder we'll generate. I'm also going to generate a file name variable, so dim file name as string, and that will hold the file name for each file or each film we look at. And I'm also going to finally count the number of columns in the data set. So I'm going to say dim cols as integer, just to hold the number of columns that I'm going to loop over to write out into the text file. Next, let's generate the folder that I want to store these files in. I'm going to store these all on my desktop, which currently there isn't a folder on the desktop that's got this folder on it. So what I would like to be able to do is check if the folder exists, delete the existing copy, and then subsequently recreate it. So let's do that by heading back to the VB editor again, and I'm going to write a quick set of code that's going to say, first of all, folder path equals the folder path to refer to my user's desktop, so bearing in mind that it might not be me running this code, I want to make sure that I can calculate the path to the desktop using the environ function. So I can say environ and then ask for the user profile, and then I can concatenate to the end of that using the ampersand a literal string that says desktop, and then also the folder name will actually be called films. What I could then do is check if that folder exists, then delete it, subsequently recreate it. So I could say if fso.folder exists, open some parentheses, pass in the folder path that I've just concatenated, then fso.delete folder, and then I can pass in again the folder path, so that's folder path. Once that's been done, I can generate the folder again from scratch by saying fso.create folder. I can only do this if the folder doesn't exist, which is why I needed to check that it did exist first to delete it. So I can say fso.create folder and then pass in the folder path. So at that basic point there, if I were to simply run this subroutine by pressing F5, it will generate a new folder on my desktop. If I run it again, it will delete the folder and then recreate it. It might be better to step through this just to prove that it is working. So I can delete the folder and it disappears, then recreates it from scratch, and I've always got that folder available now to write these text files into. Okay, the next little bit of setting up to do is to count how many columns there are in my dataset. So when I'm looping over these individual rows, I want to make sure that I'm writing out every column of data to the text file. So a simple convenient way to count how many columns there are would be to use my cols variable and make it equal to range a1.currentRegion, which refers to the entire block of data, the entire table, and then I can refer to the columns property of that and then simply count them. So that will help me out a little bit later on as I'm looping over the files. Sorry, beg pardon, looping over the films to generate the files. So what we can do now is begin the loop. I can say for each r in, and I want to loop over every cell from range A2 down to the end of this list. So one convenient way to achieve that is to say from range A2, comma, and then to reach range A whatever, A1201-ish, I can go from cell A1, index cell down to find that cell. So I can say range A1, go from the top of the list, dot end XL down. The reason I'm excluding the first row, I'm not using range A1 here, is that I don't want to write out the title cell anywhere or the title row into the text file. I just want to write out the individual films. So close two sets of parentheses to wrap up that statement, give myself a few blank lines and then say next R to move on to the next row. And then what I can do is start building up the file name for each individual cell in this list. Now to generate the file name to begin with, all I'm going to do is say file name equals r.value ampersand and then concatenate a .txt to the end. We'll create tab delimited files for these individual films. What I'm then going to do is attempt to open up a text file with that specific name. I'm going to make sure that if the text file doesn't actually exist, then it will be created automatically. So to do that, I'm going to concatenate the folder path and a / character and whatever value is currently stored in the file name variable. So to do that, I can say set ts equals fso.open text file, then open up some parentheses. I can then concatenate the folder path with a literal / character and then with the file name variable. So file name. I want to make sure that I'm opening up the file to append new data to it rather than to read data from it. So I need to choose the for appending option for the IO mode parameter. Then I also need to specify that if the file doesn't exist, that I want to create it. So I can do that by setting the create parameter to true. Close the parentheses at that point, and then I'm going to write out some data to that text file, but I'm not going to write out that line just yet. Once I finish writing data out, let me just add a quick comment. Write to text file is another problem to solve first. Write to text, and then once I've done that, I'm going to close the text file and then set ts to be equal to nothing, and then move on to the next row in the data set to write it out to another text file. Now if I were to attempt to run this subroutine at this point, I'm going to hit a problem fairly quickly, and you'll see that I've got an error message here, runtime error, bad file name or number. If I click debug, it's of course the line that's trying to open up a text file, and in this particular case, it's the one that's trying to open up Who Framed Roger Rabbit ? Hint hint, .txt. So I've got a problem with a file name here that's got a question mark symbol in it. I've actually inadvertently created a few other problems for myself as well. If I just stop or reset that procedure and look back at my desktop, if I double click into my films folder there and then have a quick look inside here, you see I've got a huge number of different text files here, some of which look fairly sensible, but there are a few odd ones in there that don't look quite the way they should. They don't have the .txt extension, they're not listed as text documents. So for instance, Master and Commander and Mission, I don't remember a film called Mission in my list. Pirates of the Caribbean, I don't remember a film just called Pirates of the Caribbean, they all had subtitles. So that one there, if I were to look, if I just close that window down actually, have a look back at my Excel list, Pirates of the Caribbean, : at World's End. So I've clearly got a few issues here with some certain characters in my film names. And the reason for that, of course, is that there are a set of illegal characters for file names. Characters you're simply not allowed to use. If you want to know what the exact list is, there's a fascinating article. I don't really mean fascinating. On the Microsoft website, naming files, paths and namespaces, and in here is a little section about illegal characters. So it's just that little list there. There's not that many, but you can see there's a : character is one of the problems. A question mark character is another. They generate different problems, of course. So you can see that the : didn't throw a runtime error. It happily generated files, but they weren't the exact file name that I wanted. The question mark did throw a runtime error because the question mark simply can't be contained in the file name. That's used as a wildcard character in Windows operating systems. So what we need to be able to do is check if any of these characters exist. We need to replace them with, I suppose, nothing, or maybe a space, or some other legal character. So let's have a look at how we could achieve that. Now, one fairly simple approach to solving this problem would be to just write a separate replace statement for each individual character that we wanted to replace in the film's name. But that's kind of a bit boring, a bit tedious, and not very satisfying either, so we're going to take a slightly different approach. What we're going to do is create an array. We could also use a collection or a dictionary, I suppose. It doesn't really matter, but I think an array would work best for this particular example. And that array is going to contain this list of characters. And then for each film name we encounter, we're going to loop over the array contents and try to replace each different string inside the file name. So to get started, let's head back to the VB editor, and inside the same subroutine we were just working with, we're going to declare a couple of new variables. So up at the top, we're going to say dim, I'm going to call mine illegal characters, or illegal chars for short. So illegal chars, and it's going to be an empty array with no type. What I can then do as well, because I'm going to need to loop over the array later on, I'm going to declare a variant array, a variant variable, so dim v as variant. I might as well then just populate the illegal chars array right now, so I can say illegal chars equals, then there's an array function in VBA that allows you to build up essentially a list of as many different strings or numbers or dates or references that you want. So you can just write them all out from scratch. So let's have a quick look. How many have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 altogether. So I need to pass in 9 different individual strings. So each one is going to get passed inside a set of double quotes. So I'm going to type in 2 double quotes and then a comma. Then I'm going to copy those and then paste them in 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. If I take away the last comma and then replace that with a close parenthesis, that gives me a slightly easier job now of filling in the individual characters. Let me just change the width of my VB editor so I can see them a little more clearly. So the first one is a less than character, so I can type in a less than character, then a greater than, then a colon, of course. We've seen that that has a problem, gives us a problem. Then there's a double quote character. That's slightly interesting. Double quotes. If I type in a single double quote and then click away from that line, that gives me a a syntax error. So the reason for that is to insert a single double quote character as a literal character, you have to double them up in VBA. So double quotes, double quotes, double quotes, double quotes, 4 of them all in a row will give you a single double quote character. After the double quote, what do we got? We got a / character, then a / character, then a vertical bar or pipe, so that's shift and / on my keyboard, then a question mark, as we've seen, we know that one gives us a problem, and then finally the other wildcard character, an asterisk or a star. Okay, so that's all of those strings or all those individual characters stored in my array. Let's just change the width of the screen again to make it a little more readable. What we need to do now is inside our main loop, for each new file name that we encounter, we want to loop over the contents of the array and replace each character with an empty string. Let's just make a quick change to this line first. So I'm going to take away the concatenated file name extension at that point. To begin with, I just want to store the film's name in the file name variable. What I'm then going to do is use my variant variable to loop over the contents of the array. So I'll do it in a fairly simple way using a for each loop. So for each v in illegal chars, give myself a couple of blank lines and then say next v. And for each one of those, what I would like to do is set the file name to be equal to the replaced version of the file name. So replace file name, and I'm going to look for the contents of the variable, so whichever individual character I'm looking at to start with, I want to replace that with an empty string. So open some double quotes, close some double quotes. I could put in a space if I prefer, or some other legal character, but I think an empty string would work best for this particular example. If I close the parentheses at that point, just after I've finished looping, to make sure we add on the final extension to the file name, let's say file name equals itself ampersand open some double quotes .txt close double quotes. Okay, so at that point we should be ready to give this a quick test. Let's just run the subroutine, and it might take a little tiny bit longer to run than it did before, but it seems to have happened fairly quickly. And if we switch back to the desktop and have a look into this films folder, we've got a separate text file for every individual film, so 1,157 different text files. The sad thing is there isn't really anything contained in those text files at this point. So the last step of the entire process is to make sure that we write out the contents or the details for each film for that particular file. So let's just close down that window, head back to the VB editor and wrap things up with this last little part. Now, in order to do this, I'm going to use the same technique I used in the previous video in this series, which is talking about joining strings. So I'm going to use the join function and the transpose function to achieve what I'm trying to achieve here. So underneath my comment here, write to text, I'm going to say ts.writeLine, which will write an entire line into the text file, of course. I'm going to give myself a space underscore to move on to the next line, because I need to write a relatively long expression to make this work. So I'm going to use the join function, which we covered in detail in the previous video. So I'm not going to explain how this works right now. Have a look at the previous video if you want the absolute detail of this. But basically, the join function requires some sort of array, which you then specify the delimiter for, and it will take the contents of the array and join it into a single continuous string. So what I could do, completely pointless at this point of course, is I could refer to my illegal chars array and then say separate them with a tab character, and it would put all of these individual strings into a single continuous one. That's not what we're trying to do, of course. What we're trying to do is take the contents of a row of data from the worksheet. So I can refer to the first cell of that row with the letter R, and then I can refer to the rest of that row by resizing it. So I can say r.resize. Then I can open up some parentheses and I can specify the number of rows I want, which will be 1, and the number of columns that I want, which will be equal to the number stored in my cols variable from earlier on. So I can say cols, then close the parentheses and say .value. Now, the problem with that is that, unfortunately, that reference to that range of cells doesn't return an array that can be passed into the join function. I also want to specify the delimiter character for the join as well. So just after the value, I'm going to type in a comma, followed by, I'm going to go with a VB tab to generate tab delimited files. So, the problem that I've got, as I was mentioning, is that this isn't a valid value to pass into the join function. I need to convert this into a single dimensional array, and currently it's a double dimensional, a two-dimensional array. So the way that you do this, slightly bizarrely, just go with it for now, and again, the previous video gives you the details of this. I'm going to say application.transpose r.resize1 cols value, and then I'm going to transpose that again. So I'm going to transpose it twice, which will convert the two-dimensional array into a single-dimensional array. So I'm going to copy and paste application.transpose, and then just make sure that I've closed the correct number of parentheses. And having done that, what I can finally do is run the entire procedure. It will get rid of the old file and generate a new folder with all those files. Shouldn't take too long. Finally, if I now go back to the films folder, give that a quick double click, I will have a whole bunch of different files with different bits of information in them. Some more heavily populated than others, of course. So let's have a quick look if I can find something like, let's find one, Anna Karenina. I know that one's got quite a lot of different versions. So let's have a look. There she is. So there's 4 different versions of that film in there. And likewise King Kong and various other examples too. So, slightly more complex actual practical example of using the replace function, but hopefully you can see that all the techniques, the basic techniques we were looking at back in Module 1, are relevant and important for this slightly more complex practical use. Hope you found that one useful anyway. Thanks for watching. See you next time. If you like what you've seen here, why not head over to the YSL website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.